Okay, so on this lesson, we're going to continue the exponential growth and decay. We did this yesterday. And now what I need you to do is on the back side, go ahead and copy this down. I'm going to assume you already did that, and we're just going to go ahead and jump right in. Hey, this looks very similar to what we did yesterday, except this is the formula for compound interest. Interest is what the banks will give you for you lending them your money. What does that mean? Like, let's say I have like $1,000 that I don't want to keep at home, right? I don't want to keep it under my couch or under my bed or anything like that. So I take my money and I go over to the bank and I say, here you go, bank, go ahead and hold on to my money for now. I want you to go ahead and keep it nice and safe. Now, because the bank is holding on to my money, that is my money and they have it. That is like they are borrowing the money from me. So what does the bank do? They say, hey, Mr. Luchuka, thank you for letting me borrow your money. Every once in a while, I'm going to go ahead and cut you a little bit of a check, which we call interest. They give me money. They pay me for the ability to hold on to my money. Okay. Now, it works backwards too. If I go to the bank and I ask them for money, I would be borrowing their money, right? And in that case, I would have to pay them interest. And that's what happens a lot when like you buy a house, right? Obviously, most people don't have enough money to buy a house right away. So they ask them to borrow money from a bank and then they have to pay interest on that loan. Okay. All right. So because different banks work differently, some banks will give you the interest every single day. Now, if they're going to give you the interest every single day, that means they're going to give you a little bit of money every single day. Okay, it doesn't mean like they're going to give you a ton. Most banks give you the money every single month, so they'll give you a little bit more than what it is daily, um, but they do it 12 times a year, right? As far as other banks, they'll do it quarterly. Quarterly means 4 times a year. That's why you're seeing these numbers here on the right. Some banks will do it semi-annually. That's kind of rare, but it does happen. Semi-annually means twice a year. And then some banks will just only do it once, and they call that annually. And it's just one time, all right? So those are the numbers associated with how many times you get your paychecks or how many times it's being compounded. Are they doing it every day, every month, or 4 times a year, 2 times a year, or just once a year? Regardless, we have our formula for this. Let's go ahead and give you some statements like we did on the last one, what this means. Just like last time, your Y is going to be your final amount. That's how much you're going to end up with once the time has elapsed. And A, just like last time, is going to be your starting amount. So this is what you would be putting in the bank to start off with. I hope you remember why that one is there. That one is there because everything is based off of 100%. Okay. The R is going to be your interest rate because this formula works for interest. So it's not your growth rate, it's not your decay rate, it is your interest rate. Now, I also forgot to mention, you see how this is a plus? That's because your money will always be growing. There is not going to be a case where your money will be decaying under these circumstances when it relates to interest. So we put a plus sign in between. Okay. And then the N is the new addition to this thing. This is the number of times it's being compounded. What I mean by that, like, are you doing it daily? Are you doing it quarterly? Are you doing it monthly? Most banks would be doing it monthly. Number of times it's being compounded. That's this N. What about the other N? Well, it's the exact same thing, right? So you're gonna be writing down the number twice, once on the denominator and the other time up in the exponent. And then the T still stands for what it stood for before, which is going to be how much time has elapsed. Okay, so let's go ahead and read the first question and let's see how this formula comes to be. It says you deposit $200 into an account that earns 5% interest compounded monthly. How much money will you have after 4 years? So let's say I have $200. The bank says, hey, you're going to get 5% interest each, and it's being compounded monthly. And I decide I'm going to leave it in there for 4 years, and I'm not going to touch it. I'm just going to let it sit there. Okay. So let's see how this is going to work. Well, let's pick off like the important details. I know that this $200 is going to be important. This is my starting amount. What are some other key words here that stand out to me? Well, I see this 5%. Whoops, wrong way. I see this 5% right here, and that 5% is my interest rate. What else stands out? I see that this is going on for 4 years. 4 years is how much time? And you would think that that's it because those are all the numbers, but there is one more thing that's standing out that is super important, and that's it, that it's being compounded monthly. This compounded monthly, this tells me how it's being compounded, which means it's going to be compounded 12 times during the year. Okay. Okay, so let's go ahead and write down the formula. I'm going to write down the basic formula, which is the interest formula that I have up there. The formula goes like this. It's y equals a times 1 plus r over n to the nt. Let's go ahead and start plugging in some of my values. Y equals my initial amount, we said was 200 times 1 plus my R stands for the interest rate. They said the interest rate was 5%. I would love to put 5% in there, except my calculator is probably not going to handle that too well. So let me write 5%, but let me change it to a decimal. That's something my calculator will be able to handle way better. I'm going to put the decimal at the end, and to change it to a decimal, I'm going to put it once, twice to the left, and put a decimal there. That means this must be 0.05 divided by n is the number of times it's being compounded. And since they said it's monthly, then that must be 12 times during the year. I see an n on top again. That means I'm going to put another 12 up there. And remember that the t represents how much time. Well, they said that we were going to leave it in there for 4 years. Okay, so I'm going to put a 4 up in the exponent. Okay, now depending on your calculator, if you have a TI-30X2S, you might be able to do a lot of this at the same time. What I'm saying is I would type exactly this into my calculator and then just hit enter and leave it there, okay? But some of us don't have that. So what I would do is I would take 0.05 and divide it by 12. So let me go ahead and do that on my calculator right now. I'm going to take 0.05 and I'm going to divide that by 12. Now, what I end up with is this ugly, ugly decimal. It says 0.004166666666. On your calculator, it might say 66667. It just depends on your calculator. But mine has a bunch of sixes. And I'm not done because I just finished out this part. Because again, we're doing order of operations. Sorry, I forgot to mention. We got to do inside the parentheses first, and division is more important than addition. Okay, so I divided first. Now that I have that number, now I'm going to go ahead and add 1 to it. So let me see, plus 1. And what I get is I'm going to write a bunch of decimals. Obviously, I can't write them all, but I'm going to try to write as many as I can. Y equals 200 times 1.0041666666, and I'm just going to stop there, okay? On the top, that's a 12 times 4, and that's going to be a 48. Okay, now all I have to do is plug all that into my calculator like we were doing yesterday. I showed you how to do that yesterday. We're just going to type all that in. So let's see, 200 and then parentheses 1.00416666. Close my parentheses and raise it using that little arrow button to the 48 power. If you are not using a TI-30X2S, instead of an arrow button, like a little caret symbol or whatever, like this thing that looks like this, a button that looks like that, you might have a button that says X to the Y instead, and that's also an exponent button. So the exponent button 48, What I end up with is 244.1789931. Oh my gosh, there's so many decimals. Hey, before I write even more decimals, let's just understand what it is that I just found. I just found the amount of money I'm going to end up with. Well, if we're talking about money, then that means this must be $244 right here. And what the heck is all of this? These are the cents. But remember, with cents, we only use two decimal places. So I'm only going to use the 17 right here, and I'm going to ignore this. Kind of. Because the one after the 17, the 8, will determine if I get an extra penny or not. If it's 5 or more, I get an extra penny, and it is 5 or more. So instead of 17 cents, I do get an extra penny. This becomes 18 cents when you round it. And we are done. What did I just find out? I found out that if I deposit $200 into an account at 5% interest, that's being compounded monthly, and I leave it in there for 4 years, what I end up with is a $244.18 bank account. Now, here's where we have to be careful. Does that mean I earned $244.18 worth of interest? No, I did not earn $244.18 worth of interest. Because remember, I started off with $200 to begin with. So I guess my question is, how much extra money did I get from leaving it in there for 4 years? Well, if I ended up with 244.18 and I started off with 200, then that means I got an extra $44.18. So you have to be careful with the question. If the question asks you, hey, how much money are you going to have after 4 years? The answer is going to be $244.18. That's how much money you're going to have after 4 years. If the question asks you, how much interest did you earn after 4 years? Then the answer is I earned $44.18. Now, the really cool thing about that, guys, is I want you to understand, hey, what did I do to get those $44.18? I did absolutely nothing. I just let my money sit there in the account and it made money for you, right? Like my money made money, which is really, really nice if you know how to play with that. Okay. All right. So that takes care of the first one. I'm going to go a little bit faster on the second one so that way the video is not insanely long. It says you deposit $5,000 into an account that earns 8% interest compounded quarterly. How much money will you have after 6 years? Okay, so again, this is an interest problem, right? So I'm going to use the interest formula. The only time you use this formula is when they're talking about interest. If they're talking about decay, don't use this formula. It is only for interest, okay? So let's go ahead and start highlighting some of this stuff. What's important to me? I see the $5,000. That's probably going to be important. This is going to be my starting account amount, which I'm going to say this is going to be my A. All right, what else do I know? I know I'm going to get 8% interest. That's the second time I do that, guys. I'm sorry. I know I'm going to get 8% interest. And if I'm talking 8% interest, this must be my rate. That's the letter R. What else do I know? I see 6 years. And if we're talking about 6 years, that must be my time. And then the one that's always kind of sneaky is the key word, right? It looks like that's all there is, but no, you need to know how it's being compounded. This is going to be compounded quarterly, which means it's going to be compounded 4 times. This must be my N. That's how it's being compounded. Okay, let's go ahead and set it into the formula. This is going to be y equals a times 1 plus r over n to the nt. I get y equals my starting amount. My a was 5,000 times 1 plus my interest rate was 8%, but remember, we do not use percentage signs on formulas. So I'm going to change this to a decimal, and I'm going to move that decimal 2 times to the left, and I get 0.08 divided by my N is quarterly, and quarterly means 4 times a year. So I'm going to divide by 4, and I'm going to raise it to the 4th power. My amount of time in this case is going to be 6 years, so I put a 6 here. And now I can use my calculator. All right, calculator, you work from the inside out. So first, PEMDAS, I'm going to do the parentheses. And division's more important, so I'm going to go 0.08 divided by 4. This time, that's a nice decimal. That's like 0.02. And then I'm going to add 1 to it, and I get 1.02. So I get y equals 5,000 times 1.02. 4 times 6, that's going to give me a 24. Now that I have that, I'm just going to go ahead and type all that into my calculator. 5,000 parentheses 1.02, close my parentheses, and then raise it to the 24th power. When I hit enter, I get a long decimal. So let me write what I have. That's y equals 8,042.186243737, and it goes on and on and on and on. This is money, right? So I know that the initial 8,042 is how many dollars? I also know that the next two decimals means 18 cents. These other decimals don't really matter except for that 6. This is 18 cents. This 6 is going to tell me if I get an extra penny or not. If it's 5 or more, I get an extra penny. And it's 5 or more, I get an extra penny. So instead of 18 cents, this is going to be 19 cents. So I erase all these numbers, and I change this to a 9. What does the $8,042.19 mean? That means after 6 years, if I invested $5,000 at 8%, that's being compounded quarterly, my bank account is going to have $8,042.19 in it. Does that mean that's how much money I got in interest? No, that's how much money I have total, okay? How much I found in interest, remember I started with $5,000, so I take my money that I have now and take away the initial $5,000 that I started off with. That means I must have earned $3,042.19 of interest. It matters what the question is asking. If they ask me how much money will I have after 6 years, which is what this question asked, it would be this. That's my answer. I ended up with $8,042.19. If they ask me how much interest did you make, then the answer is $3,042.19. Okay, that's all the time for today. As always, if you have any questions, please feel free to ask.